Okay, section 4.2. We have quite a few examples here, so there'll probably be a part 1, a part 2, and probably even a part 3. And these first examples we're going to look at all have to do with the multiplication rule. There's going to be ands, okay? So the probability of A times the probability of B given A did occur, okay? So let's look at this first example. Roll a die 3 times. What is the probability of a 2 and a 5 and a 2? Well, so we're going to do the probability of a 2 times the probability of a 5, assuming we got a 2 on the first roll, and a probability of a 2 on the third roll, assuming we got a 2 and a 5 on the first and second roll. Now, the thing about a die is whatever you roll the first time has absolutely no effect on probabilities when you roll the second time. These events are independent events. So the probability of rolling a 2 on a die is 1/6. Well, even if we assume we got a 2 that first time, that's not going to change the probability of a 5. Rolling a 5 on a die is the probability of 1/6. Okay? And then again, it doesn't matter what we rolled these first 2 times. The probability of rolling a 2 on the third roll is a 1/6. So we do 1/6 times 1/6 times 1/6, which was 1/216. Okay? All right, let's draw 2 cards, but we're going to replace the first card before we draw the second card. Okay? So we want the probability of a king and a 7. So the probability of a king times the probability of a 7, assuming we got a king on that first draw. So that when we go to draw that first card, the probability of getting a king is 4 out of 52. Now, we assume we got a king, but we're putting it back in, so it has absolutely no effect on this probability of getting a 7. There's 4 7s out of the 52 cards. Multiply across, we get 16 out of 2,704. Now let's find that same probability, but we're going to draw 2 cards without replacement. What that means is that we're going to pull that first card out and we're going to leave it out to draw the second card. So again, we want the probability of a king and a 7. So the probability of a king, there's 4 out of 52 times. Now, assuming we got a king, we left it out. Now there's 4 7s out of 51 cards. Multiply straight across, we get 16 out of 2,652. Now, getting a king and a 7 on this one is not independent because the first event happening does change the probability of the second event. All right, now we're going to draw 3 cards without replacement, and we want the probability of an ace and an ace and an ace. So the first time we draw, there are 4 aces out of 52 cards. Now, we assume we got an ace. We are leaving it out. So now on our second draw, we only have 3 aces out of 51 cards to choose from. Okay? Then again, we assume we got an ace. Now on our third draw, there's 2 aces out of 50 cards. And so we multiply straight across and we get 24 out of 132,600. Okay? So that's our multiplication rule. All right, now we're going to look at some ORs. These are the addition rule. The probability of event A plus the probability of event B minus the probability of A and B. Okay? So now we're only going to roll a die once. And we want the probability that it's either a 2 or a 5. So when we roll a die, the probability of getting a 2 is just 1/6. Okay? Plus, then the probability of rolling a 5 is 1/6. Now, if we are rolling a die one time, is it possible to get a 2 and a 5 at the same time? No, it is impossible, so that probability is 0. Okay? These events are mutually exclusive because you cannot get a 2 and a 5 at the same time. Okay? So you just have 1/6 plus 1/6 minus 0 is 2/6. Okay? Or 1/3. All right. Now we draw 1 card. What's the probability that it's a king or a 7? So again, this is our addition rule. So the probability of a king, well, there's 4 out of 52. plus the probability out of a 7. There's 4 out of 52. Now we're only drawing one card. Can we get both a king and a 7? That's not possible, so that probability would be a 0. Okay? So 4 out of 52 plus 4 out of 52 minus 0 is 8 out of 52. Again, if you're drawing one card, it cannot be a king and a 7 at the same time, so these are mutually exclusive events. Okay? All right, let's draw one card. What is the probability of a king or a heart? All right, so again, additional. The probability of a king is 4 out of 52. The probability of a heart is 13 out of 52. Well, is it possible if you're drawing one card to get a king and a heart at the same time? Well, sure, the king of hearts. Okay, how many king of hearts are in the deck? 1, so we're subtracting out 1 out of 52. And this makes sense because these 4 kings included the king of hearts. These 13 hearts included the king of hearts, so it got counted twice. Okay, so this addition rule, if our events can happen at the same time, then we're doubling things and they have to get taken out. So 4 50-seconds plus 13 50-seconds minus 1 50-second is 16 out of 52. Okay? All right, I am going to stop right there and continue on the next video.